Let's talk about homogeneous linear equations with constant coefficients. A body with mass 1 kilogram is attached to a spring with spring constant 4. So again, we have this spring over here, and then there's some mass attached to it. The damping constant for this system is 5, so there might be something to damp down the motion, something like a shock absorber or something called a dash pot. Find a differential equation for the position y of t of the body. Let's do that. So if we have an object with mass m attached to a spring with spring constant k, and the damping constant for the system is b, then the position y of t of the object satisfies the differential equation my double prime of t plus by prime of t plus ky of t equals 0. In this case, the mass m is 1, so that's going to be our m here. B is the damping constant, so that's going to be 5. And we're told that K, the spring constant, is 4. So K is going to be 4. Okay, so we get the differential equation y double prime of t plus 5y prime of t plus 4y of t equals 0. This is a homogeneous linear equation with constant coefficients. It's homogeneous because the right side is 0. That's what it means to be homogeneous. It's linear because it's not y double prime squared or anything like that. It's just some function of t times y double prime plus some function of t times y prime plus some function of t times y. In this case, those functions of t are just constants. So it's a homogeneous linear equation with constant coefficients. Ignore the fact that it says equations. That was my bad. Okay, find the general solution for the differential equation y double prime of t plus 5y prime of t plus 4y of t equals 0. We can do that. The solution to a homogeneous linear equation with constant coefficients is of the form e to the r of t. So let's assume that y equals e to the r of t, y prime is r e to the r of t, and y double prime is r squared e to the r of t. Let's just go ahead and plug those. Let's just plug these into the equation. And when we do that, we get y double prime, well, we plug it into the equation, y double prime plus 5y prime plus 4y equals 0. And we get this equation, r squared e to the r of t plus 5r e to the r of t plus 4 e to the r of t equals 0. Notice that we can factor an e to the r of t, and we get e to the r of t times r squared plus 5r plus 4 equals 0. Now, the only way that this can be 0 is if one of these factors is 0. Well, e to the r of t can never be 0. So that means that r squared plus 5r plus 4 equals 0. In the future, we're just going to jump from this step down to this step. So we're going to avoid all the rigmarole. We can just go from y double prime plus 5y prime plus 4y to r squared plus 5r plus 4 equals 0. Okay. So here's our equation. Just ignore that. We don't need that anymore. So we have r plus 1 times r plus 4 equals 0. In other words, r plus 1 equals 0, r plus 4 equals 0. So r equals negative 1 or r equals 4. Again, recall that our general solution was of the form y equals e to the r of t. That means we have y equals e to the negative 1t, y equals e to the negative t, and y equals e to the negative 4t. This leads to e to the negative 4t. So those are our two solutions. But there's the principle of superposition. If y1 and y2 are the solutions to a homogeneous linear differential equation, then the general solution is y equals c1y1 plus c2y2. And then the general solution to our differential equation is going to be y equals c1 e to the negative t, that's what we have over here, and c2 e to the negative 4t. Solve the initial value problem, y double prime plus 5y prime plus 4y equals 0, y of 0 equals 7, v of 0 equals negative 16. That again was our original equation. Okay, so we've got our differential equation, we've got this. We found the general solution. Now let's find a particular solution such that y of 0 equals 7 and v of 0 equals negative 16. So in other words, find the solution if the initial position is y of 0 equals 7 and the initial velocity is v of 0 equals negative 16. The general solution of our differential equation is y equals c1 e to the negative t plus c2 e to the negative 4t. We saw that a moment ago. So let's plug in what we know. Let's plug in t equals 0. We get y of 0 equals c1 e to the negative 0 plus c2 e to the negative 4 times 0. In other words, 7, because y of 0 equals 7, we saw that a moment ago, y of 0 equals 7, equals c1 plus c2, because e to the 0 equals 0, or equals 1. Okay, so we know we have this equation, 7 equals c1 plus c2. Now, let's use the fact that v of 0 equals negative 16. What does that lead to? So let's see. So we have our general solution looks like this. We need to look at v of 0, in other words, y prime of 0. So let's take the derivative. We get y prime of t equals negative c1 e to the negative t minus 4c2 e to the negative 4t. Let's plug in t equals 0. We get y prime of 0 equals negative c1 e to the negative 0 minus 4c2 e to the negative 4 times 0. Well, y prime of 0 is negative 16, so we can plug that in. And the right side is just negative c1 minus 4c2. So we have two equations. We have 7 equals c1 plus c2, and we have 16 equals negative c1 minus 4c2. The solution to this system of equations is c1 equals 4, c2 equals 3. That means, again, going back over here, the general solution to our differential equation looks like this. That means the solution to our differential equation, this initial value problem, is y equals 4 e to the negative t plus 3 e to the negative 4t. Find the general solution for the differential equation y double prime of t minus 7y prime of t equals 0. Again, our solution is going to be of the form e to the r of t, so we're just going to jump straight from this to the equation r squared minus 7r equals 0. Factor that is r times r minus 7 equals 0, so r equals 0 or r equals 7. So our solution is y of t equals c1 e to the 0t plus c2 e to the 7t. E to the 0t is just 1. So in other words, we have y of t equals c1 plus c2 e to the 7t. Let's find the general solution for the differential equation y double prime minus 10y prime plus 25y equals 0. Again, the solution is going to be the form e to the r of t because this is a homogeneous linear differential equation with constant coefficients. So we have r squared minus 10r plus 25 equals 0. That can be factored as r minus 5 times r minus 5 equals 0. So our solution is r equals 5. Notice we have a double root. Okay, we have r equals 5 as a double solution. It's a solution with multiplicity 2. When there's a double root like this, one solution is going to be e to the 5t, and then the other is not going to be e to the 5t as well. The other one is going to be t e to the 5t. So in this case, we have y of t equals c1 e to the 5t plus c2 e to the t e to the 5t. Okay, let's find a general solution for the differential equation y double prime of t plus 36y of t equals 0. We get r squared plus 36 equals 0. So r squared equals negative 36. Do you remember from years and years ago how to solve r squared equals negative 36? Solutions are going to be r equals plus or minus 6i. So we just plug that in for r. Y of t equals c1 e to the 6it plus c2 e to the negative 6it. This can actually simplify dramatically to c1 cosine 6t plus c2 sine 6t, and I'll show you in a moment why. In general, if r equals the complex number a plus or minus bi, then y of t equals c1 e to the at cosine bt plus c2 e to the at sine bt. Okay, you don't need to know. So we already have our solution. Okay, this is our solution. That's the general solution for the differential equation. So you don't need to know why y of t equals c1 6it plus c2 e to the negative 6it can be rewritten as y of t equals c1 cosine 6t plus c2 6 sine t. But I'm going to tell you anyway. Recall Euler's formula. E to the a plus bi equals e to the a times cosine b plus I sine b. So let's apply that to the exponent 6it. So we have c1 e to the 6it plus c2 e to the negative 6it. And we're going to end up with c1 cosine 6t plus I sine 6t plus c2 cosine 6t plus I sine negative 6t. So we can distribute the c1s. We have c1 cosine 6t plus IC1 6 sine 6t plus c2 cosine negative 6t plus IC2 sine negative 6t. Let's group like terms. So we've got c1s here. We group the c1 terms. We have c1 cosine 6t plus IC1 sine 6t plus c2 cosine 6t minus I C2 sine 6t. So again, we're just grouping the, we're just multiplying that out. Oh, actually, what we're doing at this stage is using the fact that cosine of negative 6t is cosine 6t, and sine of negative 6t, sine of negative 6t is negative sine 6t, because sine is an odd function and cosine is an even function. Okay, so y of t equals c1 plus c2 cosine 6t plus ic1 minus ic2 sine 6t. We're just grouping the cosine 6t and the sine 6t. Well, we're just going to call this constant. These are all just constants. So we're going to call this thing c1, and we're going to call this c2. So that's why y of t equals c1 cosine 6t plus c2 sine 6t. Do you need to know that? No, you really don't need to know that, but I just felt an obligation to tell you anyway.